Alright, so in this chapter we're going to look at some statistics, and we're going to give a broad overview, so we're not going to dig too much into the weeds of things like hypothesis testing. That's more for the Math 212 that we offer. So this is sort of an intro, a very general overview about how to understand and a little bit calculate with statistics. So statistics is basically about collecting, organizing, analyzing, and drawing conclusions from data. And if you don't remember anything else, remember this. Statistics is looking at the group, not the individual. And so we'll talk about how to interpret statistics in a little bit, but you always have to keep in mind when you read statistics that we're looking at the group, not a single person. Now, we're going to look at statistics in the sense of just collecting data. And data are the actual values that we're collecting. We're going to collect those values in association with the characteristics. The characteristics are the variables, and the values are the data. Okay? So for instance, if I say I have a height of 5 foot 7 inches, height is the variable, and 5 foot 7 inches would be the data value. All right? If I said I am male, well, the gender is the characteristic, that's the variable, and male would be the value in that case. Another distinction that we have to look at is the idea of populations and samples. Now, we all think of population as the big set, population, and a sample being a subset of that. And that's a good way to describe sample. Sample is a subset of the population. Now, it's a little bit harder to find population because it's a little bit unnatural of a definition. Population is the overall group to be studied. All right? Now, there's a distinction here between the words studied and do an experiment on. So, while most of the time the experiment happens inside the sample, what we're really trying to do is study the entire population. So the population is the group to be studied. Now, I want to be very clear. A lot of times a population isn't everybody in the whole world. A lot of times populations can be very specific groups. For instance, you may do a study on community college males who are attending community college right now. Well, your population is males who attend community college, and you might take a sample of those. But notice that males who attend community college can be a population, even though that excludes females, that excludes a lot of people who don't go to community college. So population is the group to be studied, sample is the subset. Now, there are lots of ways to take samples, okay? We have things like random samples. Now, when we talk about random sample, in this class, that has the idea that I didn't know how it was going to come out, all right? That's sort of it, but in general, it's the idea as we pick from hat. Everyone has the same chance of being picked, theoretically. Also, in here, you can have a computer-generated, modern-day sampling. If we would talk about random samples, Well, they take computers and generate their samples. Okay? And in modern day polling, what'll happen is they have a gigantic bank of telephone numbers, and then they call them, they have a computer basically pick out random numbers to call. Now, the next one is a systemic sample. And basically, this is when you pick every, I'll put kth person. So imagine that you stand outside of Myers and you want to sample shoppers at Myers. So you stand out. It wouldn't be, you couldn't do a random sample because you wouldn't be able to put everybody's name into a computer and then generate a sample from that. So what you may do is you may stand outside Myers, and every fifth person that walks out, you may sample. Or maybe instead of every fifth person, you might take every 15th person or every 100th person. So that's why the letter K is here, because it might be fifth, it might be 50th, it might be every 100th person. Okay. A cluster sample is the idea that you pick all at once. All right. So if we were doing the same example from Myers, well, instead of picking every 100th person, maybe you'd have picked 20 people or 100 people all at the same time. So everybody that comes out, you just pick and put them all together. Now the last one is a convenience sample. And this is characterized by the fact that it's easy to get. Alright. And it's actually not a good way of sampling. So for instance, let's take the Myers sample. Maybe all of your friends shop at Myers. So you just pick all your friends and interview them and say, well, that's my sample. Well, the fact that they were your friends means that it was easy to get. Okay? And it was convenient for you. And it pretty much also guarantees that it's not going to be a very good sample. Okay? If it's easy to get, if it's just your friends, then most likely they're not going to have the exact same demographic makeup as the population at large. Okay? One example of convenient sample that happens are internet surveys. So if you go on a website, maybe let's say it's a news website, they may have a poll, what do you approve or disapprove of the president? Well, you're going to get vastly different results based on the websites that you go to. If you go to certain websites, they may have a lot of Republicans. If you go to other websites, they may have a lot of Democrats. If you may go, lots of these things influence. So internet surveys are almost not as good. They are never as good. And they are convenience samples. Okay? Not only is it the website may be biased, but let's pretend that we're at a decent website who gets a good mix of Republicans and Democrats. Well, if you put up a survey on that website, only the people who are really vested in whatever issue it is answer the question. Okay? And so you don't get a lot of middle ground in those kinds of things. So convenient samples are really never a good thing to do. Now we'll also look at a little bit of proportions and things like that. They're in the news. They're not a lot, so I'm just going to mention them. But proportions are just percentage of the total population. A lot of times, data is given by proportion. Okay, if you go a lot of the polling that's done, they'll say 72% of Americans approve of policy X, whatever policy X is, and they're giving you a percentage of the total population. And because it's in the news a lot, it's kind of interesting to look at, although we're not going to deal with it too much in this class.